Good day and welcome to our today's class. Of course, we are on question number 5 on machine design, simple stresses and strain. Now, the question says the piston rod of a steam engine is 50 mm in diameter and 600 mm long. Now, the diameter of the piston is 400 mm and the maximum steam pressure is 0.9 Newton per millimeter square. Find the compression of the piston rod if the Young modulus of the material of the piston rod is 210 kilonewton per millimeter square. So let's bring out our parameters before we start solving. Now, we were told that the piston rod of a steam engine is 50 mm in diameter. So our data is given. We have our piston rod is 50 mm in diameter. So this is D, which is equal to what? 50 mm. Next, what do we have? We have our length of the piston rod to be 600 mm. So length is equal to 600 mm. What do we have next? We have the diameter of the piston, which is 400 mm. So we can say D is equal to what? 400 mm. Now, what do we have next? We have the maximum steam pressure, which is equal to 0.9 Newton per millimeter square. Maximum steam pressure .9 Newton per millimeter square. This is what we have. So we are told to find the compression of the piston rod. We are told to find the compression, and so of course you know that if there is a compression, that means there is a change in length. Okay, so we are told to find the compression of the piston rod if the Young modulus of the material of the piston rod is 210 kilonewton per millimeter square. So our E, which is Young modulus, is equals to 210 kilonewton per millimeter square. So now let's dive straight into it. So the first thing we are going to be looking for is our area. Of course, the area of the piston. That's the first thing we are going to be looking for, not the area of the piston rod, the area of the piston itself. So we are told that the diameter of the piston is 400 mm. So of course, with the diameter, we can find the area. So area of the piston, we can denote it by saying A1 is equal to what? It's equal to pi by 4 D square. This is what we have. Of course, we know that our D is the diameter of the piston, which is 400 mm. So if we substitute, this will be equal to what? Pi by 4 into what? 400 or squared. So this is what we have. Press this in your calculator and you have the area to be nothing but what? 125680 millimeter square. So we have this to be equal to 1265.
No, 1256.
We have 1256 millimeter square. So this is the area of the piston itself. So next, what do? We are going to be looking for what? We are going to be looking for the maximum load that is acting on the piston due to the what? Due to the steam pressure. Don't forget, we have a maximum steam pressure of 0.9 Newton per millimeter square. So we are going to be looking for the maximum load that will be acting on the piston due to the what? To the steam pressure. How do we get that? We are going to multiply the area of the piston by the maximum steam pressure. It will give us the maximum load acting on the piston due to what? Due to the maximum steam pressure. So our maximum load acting on the piston due to steam pressure, we can denote it by P. We can say it will be equal to what? Our area, which is A1, multiplied by what? Multiplied by our maximum steam pressure, which is 0.9 Newton per millimeter square. So we have 0.9 Newton per millimeter square. So now let's solve this. To get our load, P will be equal to what? Will be equal to our area, which is 125680. So I have 125680 multiplied by 0.9. So what will be our load? Of course, our load will be 113110. So we have 113110 Newton. So this is the maximum load acting on the piston due to what? Due to our steam pressure. Now we can go ahead and find the what? The compression of the piston rod. Of course, we can go ahead and do that. But before we do that, we need, in order to find the compression of the piston rod, we need the area of the piston rod. We need the area of the piston rod. Now, in order to get the area of the piston rod, of course, we are being given a diameter of 50 millimeter. So we can just go further and say our A2, which is the area of the piston rod, is nothing but what? Pi by 4 d square. If we substitute, what do we have? We have pi by 4 into what? Into 50 square. So this will be 50 all square. Press this in your calculator and A2 will be equal to what? Equal to 1964 millimeter square. So we have 1964 millimeter square. So this is what we have as our A2. Now we can go further and find the compression. We are told to find the compression of the piston rod. Now, if you recall from our formula of Young modulus, you know that Young modulus is equal to what? It's equal to stress all over strain. Where stress is what? Load all over area, and strain is what? Is change in length all over original length. So our Young modulus E is equal to what? It's equal to sigma all over what? All over E, which is our what? Our strain. This is also equal to what? Force all over area all over what? Change in length over original length. Of course, we know that we can rearrange this and say that E is equal to what? Is equal to P times L all over A times the L, which is change in length. Now, of course, you can see that we have the value of E, we have the value of P, we have the value of L, and we have the value of A. So we can just simply substitute and find the change in length. Of course, don't forget that A here will be our A2, which is the what? The area of the piston rod. So I have my A2 here. This will be the area of the piston rod. Now let's dive straight, substitute, and get our change in length for this question. So I'm going to be cleaning this part of the board as I do that. I'm going to be substituting, of course, our values in this equation to get the change in length. So our E, which is our modulus of elasticity, is nothing but 210 times 10 to the power of 3. So this will be equal to our load. Of course, our load is nothing but what? 113110. It will be multiplying our length of what? 600 millimeter. This will be all over our area, which is 1964, multiplied by our change in length. So this is what we have. So we can simplify in order to get our value for change in length. So if we cross multiply, we are going to be having 210 times 10 to the power of 3 multiplied by 1964 times change in length to be equal to what? To be equal to 113. We have 113,110 multiplied by 600. If I make change in length the subject, I'm going to be dividing both sides by its coefficient. So we have 210 times 10 to the power of 3 multiplied by 1964. Here also, I have 210 times 10 to the power of 3 multiplied by 1964. So you agree with me that this, we go with this, and we are going to be left with change in length equal to what? 113,110 multiplied by 600 all over 210 times 10 to the power of 3 multiplied by 1964. Of course, if you press this in your calculator, you are going to be having nothing but 0.165 millimeter. So we have 0.165 millimeter as our change in length. I hope you comprehend and understand this problem. Thank you for watching and have a nice time.